Greetings and welcome to a series of lectures on quadratic equations. 7.1 Completing the Square. So when we're completing the square, what we're talking about is generally on the left-hand side we have something that is squared and then we have a value on the right-hand side. So let's consider a problem like x squared equals 16. In our old way of solving this, what we would have done is bring the 16 over to the left-hand side and set it to 0. And then we're going to factor x squared minus 16 into x minus 4, x plus 4. We're going to use the zero factor property to solve each one of these factors. X minus 4 equals 0, and x plus 4 equals 0, giving us x equals 4 and x equals negative 4. So that's our old way of doing things. So now let's take a peek at the new way of doing things. Well, how we're going to do is we'll start off with the same problem, but what we want is all of the squaring on the left and anything else on the right. Okay. Then we're just going to take the square root of both sides. The square root of x squared will equal the square root of 16, and it will also equal negative square root of 16. Well, the square root of x squared is x, and the square root of 16 is 4, and the square root of x, let me say that again, x squared, the square root of x squared, there we go, negative square root of 16 is negative 4. So our solution set is negative 4 and 4. That brings us to our new property, the square root property for equations. If a squared equals b, where b is a real number, then a equals the square root of b, or a equals the negative square root of b. We have a shorthand notation for this, which would be a equals plus or minus the square root of b. Let's work with a problem that will use this property for the solution. We have 2x minus 3 quantity squared equals 25. So we're going to use the square root property for equations to be able to solve this. First step is to take the square root of both sides. Now that breaks it down into 2x minus 3 equals the square root of 25, and 2x minus 3 equals the negative square root of 25. Well, square root of 25 is 5, so we have 2x minus 3 equals 5. And I'll just work with the left-hand side for now. Add 3 to both sides, and we get 2x equals 8, so x equals 4. For the negative square root, the negative square root of 25 is negative 5. Add 3 to both sides. 2x equals negative 2. And therefore divide each side by 2, x equals negative 1. So our solution set is negative 1, 4. Now remember that shorthand notation? Well, we can use that. Let's go back and do the same problem. 2x minus 3 quantity squared equals 25. So when I take the square root for both sides, I'm going to say plus or minus the square root of 25. From here, I get 2x minus 3 equals plus or minus 5. Add 3 to both sides. 2x equals 3 plus or minus 5. Because it's plus or minus, I can't just add 3 to the 5. I have to keep it separate for now. Divide 2 for both sides. So I get x equals 3 plus or minus 5 all over 2. At this point, I have to break this problem apart to solve it. Okay, to find the solution set. One of my equations is going to be x equals 3 plus 5 over 2, all over 2. And the other one will be x equals 3 minus 5 all over 2. Okay, 3 plus 5 is 8. 8 divided by 2 is 4. And 3 minus 5 is negative 2 divided by 2 is negative 1. We still get the same solution set, negative 1 and 4. All right, let's tackle a little bit more challenging problem here. So 3x minus 1 quantity squared equals negative 12. So I'm going to go ahead and rewrite the problem. And I will take the square root of both sides. So let's take the square root of 3x minus 1 quantity squared, and that will equal, I'll do the shorthand version, plus or minus the square root of negative 12. Okay. Well, the square root of square negate each other, so it will be 3x minus 1 equals plus or minus the square root of negative 12. Okay. I can simplify the square root of negative 12. Well, the negative will be I, and 12 is 4 times 3, so the 4 can pop out as a 2, and therefore we get 2i square roots of 3. All right, so let me rewrite it. 3x minus 1 equals plus or minus 2i square root of 3. Okay. Now, I go on to solve the problem. Add 1 to both sides. 3x equals 1 plus or minus 2i square root of 3. Divide by 3 to both sides. X will equal 1 plus or minus 2i square root of 3 all over 3. Now, if this was on a test and your instructor was accepting these compound answers, that's fine. But the real solution set, you should break it apart. 1 minus 2 square root of 1 minus 2i square root of 3 all over 3, and 1 plus 2i square root of 3 all over 3. So there's two answers. Separate answers. When you're writing it in this shorthand notation, you really should break it apart in the end. So let's take another look at a problem, but this time it doesn't quite look like it fits in our form. Remember, we want the left-hand side to be a square of something, so I can take the square root of it. Excuse me. So let's look at x squared plus 6x plus 9 and see if that is a perfect square. 3 squared is 9, and 2 times 3 is 6, so this is a perfect square. It will look like x plus 3 squared equals 12. And now that I have it in that form, where the left-hand side is a squared is something squared, I can take the square root of both. So x plus 3 quantity squared, the square root will equal plus or minus the square root of 12. Probably should have done that in red just so it stands out. Plus or minus the square root of 12. All right, as before, the square root will negate the squaring, popping out the x plus 3. And the square root of 12 we can reduce. Well, 12 is 4 times 3, and the square root of 4 is 2, so that's going to be plus or minus 2 square roots of 3. I'm going to add 3 to both sides. X equals 3 plus or minus 2 square roots of 3. Remember, there are two answers here, two solutions possible. There's 3 minus 2 square roots of 3, and 3 plus 2 square roots of 3. Here are a couple problems that you should try on your own. First one, 3x plus 2 quantity squared equals 20. Number 2, is 4x minus 3 quantity squared equals negative 50. And third one, x squared plus 10x plus 25 equals 20. Given the property of the square root property of equations, that brings us to a method that we can use called completing the square. It's just a way of transforming a quadratic equation into whatever form it is, into that form where we can solve by taking the square root of both sides. Okay, I don't want to say there are just 5 steps. There's 5 steps, and then you're going to solve the problem using addition property of equality and multiplication property of equality. But these are the steps you want to take to get it into the way that you can complete the square. The first thing to do is to write the equation in the form ax squared plus bx equals c. If a, the coefficient of the quadratic term, is not 1, we're going to divide everything by a. Okay, that way there's a 1 in front of the quadratic term. Then we're going to add b over 2, so divide b by 2, and then square it. You're going to add that to both sides. That forces the left-hand side to be a perfect square. Okay. Now, we may have to figure out what that perfect square is, but it will be a perfect binomial square. Once we get it as a square of a binomial, and we simplify the right-hand side, we're going to apply the square property, the square root property, and then we're going to solve it. So it takes about 4 steps to get it into a form that we can use the square root property. Sometimes less, but at most it's going to take 4 steps. So now that we have those 4 steps, let's actually see it. It's easier to see it than it is to kind of talk about the 4 steps. All right, so let's use this method to solve x squared minus 6x plus 5 equals 0. The first step I need to do is move this plus 5 to the right-hand side. So I have x squared minus 6x equals negative 5. Okay, now I want to force the left-hand side to be a perfect square. So I need a value to be able to do that. What I'm going to do is take the value that's in the middle, negative 6, and I divide it by 2. That gives me negative 3. And then I square negative 3, 9. 9 is what I'm going to add to both sides. X squared minus 6x plus 9 equals negative 5 plus 9. All right, so 2 numbers that multiply to 9, positive 9, but add to negative 6, x minus 3 and x minus 3. So that is x minus 3 squared. Negative 5 plus 9 is 4. Now it's in the form I need to be able to use the square root property. All right, let's take the square root of x minus 3 quantity squared. Just rewriting the problem, but I'm going to take the square root of both sides, plus or minus the square root of 4. Okay, square root of x minus 3 squared is x minus 3. Plus or minus the square root of 4 is 2. Now, I solve it. Add 3, add 3. X equals 3 plus or minus 2. But that's not our answer. I have to figure out our answer, right? I have to do that math. X equals 3 minus 2, and x equals 3 plus 2. 3 minus 2, x equals 1. 3 plus 2, x equals 5. So our solution set is 1, 5. All right, so let's try another problem. Seeing it once sometimes isn't enough, so let's see it again. First step I want to do is isolate all the x's on the left-hand side. So I'm going to add 2, giving us x squared plus 5x equals 2. Now I have to figure out how to force the left-hand side to be a perfect square. I take the middle value, divide it by 2. 5 divided by 2 is 5 halves. Then I take 5 halves and I square it, giving me 25 over 4. That's the value I add to both sides. X squared plus 5x plus 25 over 4 should equal 2 plus 25 over 4. Common denominator for the right-hand side will be 4, so that's 8 fourths plus 25 fourths. In other words, 33 fourths. X squared plus 5x plus 25 fourths on the right-hand side. Okay, I'm going to rewrite that left-hand side as a perfect square. And it's not quite simple to see it, but here's what you squared, 5 halves, so that's actually how you're going to write the perfect square. X plus 5 halves, quantity squared, equals 33 fourths. Now I'm going to take the square root of both sides. Instead of rewriting it, I'm just going to write over what I have, the square root of the left-hand side plus or minus the square root of the right-hand side. To simplify the left-hand side, the square root and the square negate each other, leaving me x plus 5 halves plus or minus. The square root of 33 over 4 can be reduced because 4 is a perfect square. The square root of 33 over 2. Now I'm just going to solve for x. Subtract 5 halves. Subtract 5 halves for both sides, giving us x equals 5 halves plus or minus the square root of 33 over 2. Now that's our answer, but to be very clear, let's write it separate. Here is our solution set. 5 halves minus the square root of 33 over 2, and 5 halves minus the square root of 33 over 2. And you can put that under the same fraction. So it looks like 5 plus the square root of 33 all over 2, and 5 minus the square root of 33 all over 2. Either one of those will work. And kind of in any order works too. You could have the addition first or the addition second. Doesn't matter. In the previous problems, the coefficient of x squared, the quadratic term, was a 1. In this case, it's not, and we do have to deal with that. So let's go ahead and divide each of the terms by 3. 3x squared minus 8x plus 7 equals 0, and I'm going to divide each side by 3. Well, that's going to be 3 divided into 3 is 1. 8 divided by 3 is just 8/3. And 7 divided by 3 is just 7/3. 3 goes into 0 0 times. So now I have a 1 as the coefficient of the quadratic term, the x squared. Now I'm going to continue with the rest of the procedure. First things first, let's get this 7/3 over to the other side. X squared minus 8/3 x equals negative 7/3 by subtracting 7/3 to both sides. Now I have to find what value will make my left-hand side a perfect square. All right, take that middle term, negative 8/3, divide it by 2, which is the same as negative 8/3, times by 1/2. That's negative 8/6. Negative 8/6 can be reduced to negative 4/3. And now we have to take negative 4/3 and square it. That gives us 16/9. 16/9 is what we add to both sides. Okay, x squared minus 8/3 x plus 16/9 will equal negative 7/3 plus 16/9. Very ugly, but numbers are still workable. All right. The left-hand side is a perfect square. I'll worry about this addition in just a second. X squared minus, remember, that was our perfect squared value, 4/3. Square goes on the outside, not on the inside. And now I need to work with combining the right-hand side. That's going to be negative 21/9 plus 16/9, negative 5/9. Okay, almost there. Switch that up a bit. Let's take the square root of both sides. Just remember, it's always plus or minus on the right. X minus 4/3 equals plus or minus the square root of negative 5 over 3. Why 3? Because the square root of 9 is 3. All right. Add 4/3 to both sides. X equals 4/3 plus or minus the square root of negative 5/3. There's one more step before breaking this apart. This negative, the square root of negative 5, is really x equals 4/3 plus or minus I square roots of 5 over 3. Now we can break it apart. 4/3 minus I square root of 5 over 3, and I guess I'll just do that over 1 big 3. And 4 plus I square root of 5 all over 3. That is our solution set. Okay. Lots of little steps, but they're not bad. We're repeating the same step kind of over and over depending on what, kind of no matter what the problem is. First step, we want to make sure that that coefficient in front of x squared is a 1. So if we have to, divide by that value. Second, find the value that will complete the square. Take the middle, the b value, divide it by 2, and square it. That's what you're going to add to both sides. And then we're going to take square root of both sides, simplify as much as we can, and solve for x. Okay. I don't want to say that's it. It is fairly complex, but if you follow the steps, you shouldn't get lost. Here are a couple problems you can try yourself. So the first one, x squared plus 3x minus 4 equals 0. What is the value to complete the square? And what would be the solution set? So after you solve it, what would be the solution set? And 5x squared minus 3x plus 2 equals 0. What is the value to complete the square? And also, what is the solution set for this problem? Completing the square is also useful in solving geometric problems, geometry problems. So let's say we have let's refresh our memory on a 30, 60, 90 triangle, as well as a 45, 45, 90 triangle. So generally speaking, if our shortest side of our triangle is 1 here, we could figure out the side of the hypotenuse by changing this triangle into an equilateral triangle. So 30, 60, 90, I could force it into an equilateral triangle. So let's try a problem. All right, just that problem that I was kind of talking about. Pardon my hand. If the shortest side of a 30, 60, 90 triangle is 1 inch, find the lengths of the other 2 sides. Well, we can force a 30, 60, 90 triangle to be an equilateral triangle. Now, how do we do that? Well, we put another 30, 60, 90 triangle right next to it. The bottom length will be now 2, and since all of the angles are equal, 60, 60, and 60, that means all the sides of the triangles are equal in length. So from A to D here would be 2, B to D is 2, and A to B is length 2. So now we found the hypotenuse, we just have to find the height, in essence, of our manipulated triangle. Well, we use Pythagorean theorem for that. A squared plus B squared equals C squared. But in this case, it would be AC squared plus BC squared equals AB squared. And by plugging in our values, we're looking for the line BC, that would be our x squared plus 1 squared equals 2 squared. Well, x squared plus 1 squared equals 4 squared, 4, because 2 squared is 4. X squared equals 3 by subtracting both sides. Take the square root of both sides. Therefore, x equals the square root of 3 inches, because we did start with a unit value. Okay. So let me refresh that again. We can force our single triangle that we're looking for all the sides. We're given the shortest side of 1. We can figure out the hypotenuse by manipulating our triangle to be an equilateral triangle. Therefore, the length of AD, well, AC was 1 and CD is 1, so therefore AD is 2. And since all sides of an equilateral triangle are the same, 2 on the outside, 2 on the other outside, that means this hypotenuse of the original triangle is 2. Then we use Pythagorean theorem to solve. We're getting x squared plus 1 squared equals 2 squared. Therefore, x plus 1 equals 4. Subtract 1 on both sides. X squared equals 3, and then take the square root of both sides. And yes, there is a negative square root of 3, but length isn't negative, so we can throw that one out. So the answer is x equals the square root of 3. That's it for this video lecture. Until next time, be seeing you.